Okay, 1.5, infinite limits. Now, we've discussed that the limit doesn't exist if from the left and the right it approaches two different values. If it oscillates between two right at a point, yes. And if it increases or decreases without bound. So those are all cases where it doesn't exist, right?
Yep.
And I just said we're going to be doing infinite limits. So is that a contradiction of what I just said?
Probably.
Sure.
Yeah. So technically, if something goes to infinity, it's increasing without bound, correct? So we roughly talk about our limits at infinity, but does it reach an actual value? No. Okay, so I have this equation. It's a lovely equation, 3 over x minus 2. If I graphed it, I would have a vertical asymptote at 2, yes?
Yep.
Because 2 would make the denominator 0. We know that. So from the right, as x approaches 2 from the right, it shoots to where?
As x approaches 2 from the right, it shoots to infinity.
Positive infinity.
Positive infinity.
And when x approaches 2 from the left, it shoots to negative infinity. And we know that that's the behavior at an asymptote, correct? We know it shoots either positive, negative, or both. So when we would be doing these, if I ask you what is the limit at 2, of 3 over x minus 2, you'd plug in 2 and you get 3 over 2, and so that would not give you enough solution, like you wouldn't know from there, right? So then you would say, well, let me guess, I have an asymptote at 2, and so let me check negative 4 and 4. If I put negative 4 in here, I get a positive over a negative, so we know it's going where? Down. Okay, and if I put 4, I'd have 3 over 2, so I know it's going what? Up. So right then it would tell me at 2, does this limit exist? Does it? It is. It's approaching one value at 2.
No.
No, it is not. It is increasing on the right and decreasing on the left. So there's a problem. Like we would immediately know that this doesn't work. So when I say what is the limit at 2, the answer would be no. Doesn't exist. Okay? It is decreasing and increasing without bound. But from the left, it's going to negative infinity, and from the right, it's going to infinity or positive infinity. But at 2, I could also make a table, yes? But a basic equation like this, my graph is good enough to tell me what this is doing, isn't it?
Yeah.
If I get negative, I know everything has to shoot negative. If I get positive, I know it has to shoot positive. It doesn't have to be exact. Okay. So the equal sign in the statement, the limit of f of x equals infinity, does not mean that the limit exists. It only is telling you that the limit fails to exist at x approaches c for f of x. So because it shoots to infinity, then the limit fails to exist. It's kind of a contradiction in what I'm saying. We got to wrap our heads around that. What is happening, the function is going to positive infinity, but we have learned that that means the limit, what? Does not exist. So when I get an answer
Volleyball players are dismissed.
like this,
Junior high
I would
volleyball
expect
players are-
positive infinity to be written, and then D and E. Now, would this positive infinity be enough of an explanation for why it does not exist? Maybe, maybe not. So you could add increases without bound, right? Okay, so stating that the limit is infinity is not saying that the limit exists. What is happening, it is shooting towards positive infinity. But does the limit exist?
No.
No. It's weird to wrap your head around. I know. Autumn, tell me when I'm good.
You're good.
Okay. Okay, determine the limit as x approaches 1 from the left and from the right. So 1 from the left, what's the limit?
Positive infinity.
Positive infinity. The limit from 1 from the right,
Positive infinity.
positive infinity. They are the same, yes. We said they had to approach the same value, but they're increasing without bound. So what about the next one?
As x approaches.
1 from the left.
From the left. We're approaching negative. That's not from the. Yeah, that is from the.
That is from the
So
left.
We're approaching infinity.
We're approaching infinity. But as the limit approaches x from the right,
We approach negative.
negative infinity. So this answer would be D and E, increases without bound, right?
Yeah.
What would the other reason be?
That's two different numbers.
Okay, so I would take either one of those. It increases and decreases without bound, or it approaches two different numbers. And the biggest problem is it approaches two different numbers. So that's what I would do. And I would say two different values, but that's me.
This would go.
Okay. I once had a math teacher that said you have to read my mind to find out what I want. I'm like, oh, okay, that's gonna be fun. Haven't honed those skills yet. Am I good?
Move on.
Well, are you yes or no? Look, it's a yes or no. Okay, definition of a vertical asymptote. A vertical asymptote is when the denominator is what? 0. Or like on an even root, it can't be negative, correct? It's where the discontinuity in the domain happens. So where's my vertical asymptote on A?
1. Negative 1.
Okay, how did you find that?
Because Noah told me. I set the denominator equal to 0.
Thank you. So set the denominator equal to 0 and you get negative 1. What about on B?
Plus or minus 1.
Plus or minus 1 because you would factor that. Yes? I'm going too fast for anybody?
I added 1 over and I took the square root.
Okay, you could do that. But you just can't remember that. You can't forget that it's positive and negative, right?
No, you can't. The denominator, like we did when we were graphing these 3 years ago.
And last year.
And I did really bad at it.
And in a month.
Yep.
Yep. You've done this 3 years in a row, so I'm expecting amazing things to happen.
Failed the test.
Okay, now we got cotangent. So cotangent is y over x, yes?
Yeah.
So where x is 0 is where?
No, cotangent's x over y, isn't it? Cosine over sine.
Oh, yes. Thank you. Gosh,
That's what was messing me up.
sorry. So y is equal where to 0 where?
At 0,
At 0 and
pi.
pi? Actually, I should leave off the degree, huh?
Yeah.
0 and pi, because you can only graph in radians. So vertical asymptotes are at y equals 0 pi, and then it'd be 2 pi, 3 pi, 4 pi, 5 pi, right? So plus or minus pi n. So basically the domain, right? What it can't be. Because the domain here would be x such that x cannot equal -1. Here, it would be x such that x cannot equal ±1. And here, it would be y such that y cannot equal ±πn. And I will tell you, I'm probably the only one in the world that puts the plus or minus there because they say it's implied, but it's not implied because directional, we don't usually put it in there. We don't put -2 for a negative direction, do we? We go 2 backwards. So, I'm weird. Am I good?
Everyone's different.
Okay.
Yeah, you're gonna.
Okay, determine all vertical asymptotes of this graph. Do I need my numerator?
No.
Nope, just the denominator. You can do one of two things. You can factor, or you can set it equal to 0 and take the square root. But if you take the square root, don't forget what?
Plus, minus.
Plus or minus. So, x minus 2, x plus 2. So vertical asymptotes occur at x equals plus or minus 2. So if I said state the domain, you'd write a not equal right there and put x such that. When you are finding vertical asymptotes, you are finding essentially the domain. The reason why this is in this group is because at a vertical asymptote, what does a graph do? It shoots positive or negative infinity, right? So that's why we're there. This is what's going on. I bet some of this would reduce out, wouldn't you? Ooh, we may be wrong.
Oh, yeah. So
Factor
it's
that numerator.
Not. You told us it.
I know. It'd be x
Minus,
plus 4,
and then minus.
x minus 2.
So it's just 2.
So the only vertical asymptote we have is at -2, correct?
Yeah.
But what kind of a what happens at 2?
A whole.
A hole. Also known as okay, so the vertical asymptote is at,
removable discontinuity.
right. So -2 is what kind of a discontinuity?
Removable.
Non-removable.
There's no hype in that.
I know, I just wanted one. And I don't know why. I just wanted one today. Okay, non-removables are asymptotes, correct? At
This is just
2, there's a what?
At 2.
There's a hole somewhere, right?
Yeah.
I'm going to put it up here. And what kind of discontinuity is that one? A removable. Okay, oop, I forgot a letter. But anyway, there is a question on your test that says find the points of discontinuity and state what kind they are. Okay, so you're going to have removable, non-removable, and we could have vertical asymptote, yes? But the vertical asymptote is the same as a what? Non-removable. It looks like O removable. O removable. Am I good?
yeah.
I thought that was something.
Okay. Properties of infinite limits. The sum, the difference, if you take one plus the other and shoots. I mean, these are pretty basic, guys. It tells me that the limit of f of x is positive infinity and the limit of g of x is some L. Okay? Some value. So if I add or subtract positive infinity to any number, I'm going to get what? Positive infinity. At some point, yes? Okay? If I multiply any number by positive infinity, I'm going to get what? Positive infinity. Positive if L is positive, negative if L is what? Negative, because a negative positive, right? Okay, what about a quotient? It says I take some random number divided by an infinitely large number it's going to approach what?
0.
Why?
It says so.
But why? If I take 6 and I divide it by 4, I get 3 halves, right? What if I divide it by 10?
I don't know, right?
Oh, I'm sorry. You were bragging about not doing anything.
Well, I was. Then
Okay, we'll wait till you're done writing. Similar properties hold for one-sided limits for the functions for which the limit of f of x as x approaches c as negative infinity. So the same rules would apply for negative infinity. In essence, is what it's saying. Okay, 6 divided by 4 is what?
3 halves.
3 halves. Then I get
3 fifths.
3 fifths. We're just going to go to decimals now. I get 0.006.
Yeah.
Yep. And I get point, how many zeros? 6.
Yeah.
And then I get
All of those minus 1s.
which is essentially what, guys?
0.
0. We're not saying it is 0. We're saying it approaches 0, correct? So we'll need to remember that fact because we will have some things later on that will be like, well, we've got a constant over some equation like x plus 10. Well, as x approaches infinity, what's your denominator doing? Getting larger and larger and larger and larger, right? What is it essentially then?
Infinity.
0. Well, your denominator
Okay.
is infinity. But even what if I had x minus 10 in the denominator? Wouldn't that eventually get to positive? It approaches positive infinity even if I'm minusing 10, right? Subtracting 10. It just gets there 10 units slower. So anytime you have a constant numerator and a changing denominator to infinity or negative infinity, that's going to affect your amount. It's going to end up being 0 eventually. Because negative 0 is still what? 0. Am I good? Okay. The limit of 1 as x approaches 0 was 1. Correct? That's a rule we had. And the limit as x approaches 0 of 1 over x squared is infinity. Because this would shoot this way, yes? Slow, really slow, but would it go there? Yes? So this is 1, the limit of 1, which is 1, plus the limit of 1 over x squared would give you what? Infinity.
Because property 1 theorem 1.15.
Yeah. Like you're going to remember that. You guys have to remember all those. Okay, the next one. So the limit from the left of x squared plus 2 is x squared plus 1 is 2. Okay, so that's going to be 2 divided by the limit as x approaches 1 from the left of the cotangent of pi x is negative infinity. It's going to be 0. Because that numerator is constant and that denominator is getting infinitely large whether it's positive or negative numbers, it's still infinitely large. Am I good?
Yeah.
Okay, so the limit of 3 equals 3 as x approaches positive 0 from the right, not positive 0. And the limit of cotangent of x as x approaches 0 from the right is infinity. So I have 3 times the cotangent of x. Well, our rule said it's just 3 times infinity, which I would assume you know is what? Infinity?
Because 3 is equal to 0.
But again, is infinity an answer for a limit?
No,
No. Okay.
it's a means to say it doesn't make sense.
Mm-hmm. We good?
Yeah.
That's it.